Hello viewers, today we are going to learn one of our network theorems. What are the network theorems? First we will see. These are very important tools in learning networks or sometimes say as circuit theory. So I'll have a quick overview. We need to learn Thevenin's theorem, number 2 Norton's theorem, superposition theorem, principle of superposition, intelligence, etc. Millman's. Today we are going to discuss Norton's theorem and let's see how Norton's theorem works. Norton's theorem was introduced by an American engineer, that is E.L. Norton. He was he was employed with the Bell Laboratories in USA. And according to his theorem, any two-terminal bilateral network, any two-terminal network is having voltage sources, current sources, etc. I'm just drawing one of these for a quick reference. Any two-terminal network can be replaced by a current source along with resistance, which we call it R Norton. The current we call it I Norton. The equivalent representation of this circuit is given by this circuit, that is our Norton's theorem. This is the prerequisite of the course. It is understood that you know about Norton's theorem. So I'm just quickly having a recap that whatever load we want to calculate the load current over here, this is my load, say RL. The load current is flowing as IL. If we want to calculate what is the load current, we will short the branch resistance through which the current has to be calculated. This is my two-terminal network. The current has to be calculated through this load resistance, so we will first short the branch and we will find the short circuit current ISC, which I will also call it as I Norton sometimes. This is Norton's theorem, Norton's current. After finding the Norton's current, we will look through this terminal and find out what is the equivalent resistance, that is R Norton. And then we'll replace this whole circuit by a current source, that is I Norton, and this R Norton in parallel. Then we can add any load we can replace with this, and we can find out how much current will be flowing through my load simply by a current division rule. Say IL1, this is IL. So we'll quickly do one problem which will give you a more better understanding. That suppose we are asked to find out, this is a source of 5 ampere. This is one 6 volt source, which is a voltage source, 2 ohms. This is 2 ampere. Say this is 4 ohms. Now by Norton's theorem, we are to find out the current through the 4 ohm resistance. What will be the current through the 4 ohms resistance? Say I4. How much is that? So what we need to do according to the theorem, this is a two-terminal network. We will look from this side, from the load side, and this is my two-terminal network. So I will rather do some step-by-step calculation. I will replace my load by a short circuit. So other voltage and current sources remain the same. One more thing that I should remind you, after you learn all the theorems, you are free to choose which one to use. Right now, this problem is being done through nodal analysis by Norton's theorem. It can be done by superposition as well. It can be done by Thevenin's theorem as well. Then you are free to choose. Right now, I am doing it with Norton's theorem. So I will just short circuit this branch, and thereafter I will find out what is my short circuit current. This is 5 ampere current source, this is 6 volt source, 2 ampere source once again. How may I calculate it? So this is one mesh, so I am doing, this is mesh 1, say I1 current is flowing, I am assuming I2, and here say I3 current is flowing. So I will use rather mesh current equation. So in I1, this is 2 ohms. Okay. So in mesh 1, a source of current 5 ampere is there. So I1, I can say that I1 equals to 5 ampere. And mesh 2 and mesh 3, this is a super mesh. So this, what is a super mesh once again? If in between the two meshes there is a current source, we call it a super mesh. Now for the super mesh, I will write I2 minus I3 equals to 2 ampere once again. If you have any questions regarding super mesh, I am going to solve another problem with the super mesh that will give you more idea. Right now, what is the current in these branches? This is I2 minus I3, that is equal to your 2 ampere. Now I apply KVL to the super mesh. But where is the super mesh? This is the 6 volt, then this short circuit here and here. So this is the mesh, this is my super mesh. A super mesh is a mesh in which there are two meshes. In between the two meshes there is a current source, that is called a super mesh. Now I will write the equations as per KVL. For the super mesh, I will write the equation as from the 6 volt plus to minus, I am going down the voltage, minus 6, then short circuit, come back, it is going up once again, so plus minus 2, within this is 2 ohms, and within this 2 ohms I1 and I2, both the currents are flowing. One is flowing downward, another is flowing upward. This I1 I2, remember we have assumed our current directions, so you are free to choose your current directions. Right now I have chosen it to be I1 and I2. I2 being in my super mesh, we will consider it as higher priority, so I should write as I2 first minus I1, because I am considering this mesh. Had I been considering this mesh under this circuit, so I would have used, for the mesh 1, I would have used I1 minus I2. Anyway, this super mesh does not need that calculation, so minus 6 I2 minus I2, 2 times I2 minus I1 will give you 2 I1 minus 2 I2 equals 6. That is I1 minus I2 will give you 3. Now I1 is your 5 ampere, put that. I2 is your 3. So I2 becomes 5 minus 3. That is 5 minus 3, 2 ampere. Now I2 is 2 ampere. And what is I2 minus I3 is 2. I'll put the value in this equation. I2 is 2 minus I3. 2 plus 2 equals 4 ampere. So my I3 is 4 ampere. So I have found I1, I2 and I3 right now. So what is my IN or ISC? This short circuit current is nothing but your I3, correct? So this short circuit current once again equals to your ISC, that means your I Norton. So this can be replaced, this two terminal network which I have already shown, so it can be replaced by a current source of 4 ampere. That is my I Norton. Now how would I calculate the R Norton? That means looking from this terminal, what should be the resistances when I am deactivating the sources. Remember, deactivating the sources means I am making a short circuit wherever the voltage source appears. I am making all the current sources open. So how should I draw my short circuit and open circuit calculations? Once again, I need to have this calculations, need to have some space. So looking from this terminal, looking through the load terminal, remember, so suppose this point is A, another point is B. So this is A, this is my B. You are looking from this terminal. You have got a current source in parallel. So I will open it. I will open the current sources because I want to deactivate it. I will short circuit this 6 volt source because I want to deactivate it. Then your 2 ohms appears over here, and of course I have deactivated the source, so this is also opened. To this terminal I will see what is my Norton's resistance. Norton equivalent resistance is 2 ohm. So I will put that across this, parallel to this. Now I can put any load. In this problem the load was 4 ohms, okay? So I put the 4 ohms over here. Now by current division method you can easily calculate how much current is going through your load. That is load current by current division rule 4. I want to calculate the current through 4 ohms. So in the numerator I should put 2 and addition of 4 and 2, that is 6. So it is 4 by 3 ampere. So the current, so my answer in the I4 should be equal to, so my I4 is equal to 4/3 of ampere. Now this is a very simple problem, you can say, using Norton's theorem. We'll do one more problem, because if you haven't understood what is supermesh, how I have calculated. What is a supermesh and what is a supernode? For any kind of nodal calculations, say KVL, how do I do? Suppose this is a circuit. R1, R2, R3. Sorry, this is a voltage source, say V1. So for a single loop like this, we should write V1 is equal to, say, I current is flowing, so I R1 plus R2 plus R3. That is my KVL equation. Take a more complicated circuit like say V1, this is R1, this is R2. Take another mesh, say V2, R3, R4. Assume I1 current is flowing in this mesh, I2 current is flowing in this mesh. So how to write the equation in the first mesh, that is your start from this point, start from any point. Suppose I'm starting from this point. So whenever current is flowing through a resistor, it is going through a potential difference, right? From the higher potential to the lower potential, the current flows. So if I1 current is flowing, the drop is from this side to this side. So I will calculate IR1. IR1 is plus to minus, so positive to negative. Say when I'm adding, these are all will be within the mesh, there will be a vector addition. So from positive to negative, if we are moving, so I1 times R1, so it is going down. Okay, you can take any of the nomenclature, but you should follow one. So I am taking from plus to minus, I am going down, so it is minus IR1, negative IR1. You can say this is also plus to minus, this is coming down. So within R2 we will have minus I1 times R1 times, within R2 we will have what is flowing through R2 is I1 and I2. Because I1 and I2 flowing in the opposite direction, I should write I1 minus I2. Remember, we are considering mesh 1, so I'll have to consider that I1 as the having R terms I1 minus I2. When I'll be considering the same R2 resistance in mesh 2, I will write I2 minus I1. And then equals to, then negative to positive, it is going up, increasing. So I'll use a different sign equals to this. This will be my equation number 1. For equation number 2, I will rather have calculations. I2 is flowing both with R3 and R4. So my V2 is supplying, I'm writing it a bit different way so that you can use any of these. So V2 is supplying this drop through R3 drop, R4 drop and R2 drop. What is flowing in R3 and R4 is current I2. So I2 times R3 plus R4. Then I'll add in this R2, I2 and I1 both are flowing. So I2, I'm considering mesh 2. So I2 will come first, I2 minus I1 times the R2. So this will be my V2. Now this is the way to write ordinarily how I write the equations. Suppose instead of this R2, I have got in between these two meshes, I have got some, between the two meshes I have got some current source. So how to proceed with this? Suppose I have got a current source. How am I to deal with this problem? That comes under supermesh problems. So my supermesh problem starts with considering the current source. So we'll do one of the supermesh problem, how to tackle this kind of problem. Say I have got this one. So this is 2 ohms. 1 ohm, 3 ohm, and 2 ohms, and 1 ohm, 1 again. So I've got 1, 2, 3, 3 meshes. So this will be I1. In this mesh, suppose I2 is flowing, I3 is flowing into this mesh. So I need to find, suppose I need to find the current through the 3 ohms resistance. So what is the current through the 3 ohms resistance? That is, I need to find I2 and I3 both. So if I apply KVL in the super mesh 1 and 3, this is mesh number say 1, this is the mesh number 2, this is mesh number 3. Now in between mesh number 1 and mesh number 3, we have got a current source which is of say 7 ampere. Now I need to find out the equations. Ordinarily what you would have done for the last problem you have seen, this drop is equals to I1 times I1 minus 1 times I1 minus I2 plus 2 into I1 minus I3 equals to 7. That I would have written. But how to tackle this current source in between the two? How to incorporate this? You are incorporating the voltage drops. You are adding the voltage drops. Vectorially you are adding. So how you cannot omit this. So how you should tackle? In between the two meshes, if there is a current source, we write a supermesh equation. So this constitutes a supermesh, and the supermesh starts from here, ends up over here. And I will write an equation for this branch only. So for the supermesh equation, how we write KVL is that this 7 volt, this is supplying 7 volt is supplying, it will put it on one side, 1 times, this is I1, this is I2, so I1 minus I2, then 3 ohms. So within 3 ohms what is flowing? I2. It is in between these two mesh mesh number 2, mesh number 3. So 3 times I2 I3 minus I2. I'm sorry because I'm considering this mesh. So this mesh is being considered. So in this mesh I will consider I3 minus I2, then 1 times I3. I3 is flowing, come to this point, and okay, we have reached 7 volt. So if I calculate, it should be I1 minus 4I2 plus 4I3 equals to 7. So this is my equation number 1. Within this mesh, what you will find that this I1 and I3, in this branch, both I1 and I3 are flowing. So I can write one current equation for this common boundary between the two meshes. That is the procedure to tackle this kind of problems of supermesh. That is, between the two meshes we have a common boundary in which this current source exists. So I will write I1 minus I3 equals to 7. That is my second equation. And the third equation, of course, very simple considering your mesh number 2. So for mesh 2, we will write simply I1 1 times, I'm considering mesh number 2, so I2 will come first, minus I1, this 1 ohm is in between mesh number 1 and 2, so I2 minus I1 plus 2 I2, this is separate, no doubt about this, plus 3, I'm within 3 ohms, I2 and I3 both are flowing, so I2 minus I3 equals to 0. So this will give me minus I1 plus 6I2 plus minus 3I3 equals to 0. So this is my third equation. So we have got three variables, three equations. We can solve it on the calculator, and we will get I1 at 9 ampere, I2, just simply put in your calculator, you will get it 2.5 ampere, I3 equals to 2 ampere. So now I need to find the current through 3 ohms resistance. What is that? So current through 3 ohms is I2 minus I3. So I2 is 2.5 minus 3, that is minus 0.5 ampere. What does this minus sign suggest? This minus sign, if after all calculations, if there is a minus sign in voltage or current, it suggests that whatever you have assumed, because you have assumed this current direction, right? I1, I2, I3. Whatever your assumption is, the magnitude is the same, but the direction is practically the opposite way. So how I have assumed the current in the 3 ohms? So I3 minus I in 3 ohms, that is I2 minus I3, that is 0.5. I2 I have taken I2 minus I3. So I2 minus I3 means I am preferring that I am taking the direction of I2. So it is I2 is a higher quantity than I3. Basically, this minus sign suggests that I3 is the higher quantity than I2. So the net resultant current will be flowing due to I3. So how is I3 flowing? From left to right. So oh, I have done something wrong. This is 2 ohms only. Suppose this is 3 ohms, 2 ohms, 2 ampere. So this is, no, this is plus. This is 0.5. Suppose this had been 3 ohms, 3 ampere. So I would have calculated like that. So 2.5 minus 2 in this case. This is 0.5 ampere flowing in the direction of I2. I2 is greater. Suppose this value I3 ohms comes at minus 0.5. So you have to consider the direction for I3. That means I3 is a greater quantity. What I had tried to make you understand. Thank you. And if you have any query, so you can talk to me on 9619-236-9619-06. Thank you.